Welcome to the presentation on the Automated Experiment Data Centralization System, also known as AEDCS. Your presenter today is Michael Boldashar from the University of Minnesota. Here's an outline of what we're going to discuss in this video. First, the problem. Second, an AEDCS overview. Third, an AEDCS demonstration. Here are some of the problems facing NEES sites: an increased number of data acquisition systems, large dataset sizes, slow upload speeds, upload requirements, and limited IT staff. Here's an overview of the AEDCS system. The AEDCS system is comprised of two components: the central server and AEDCS clients installed on data acquisition systems. The clients stream data to the central server, and the central server streams data to Project Warehouse. Now I'm going to show a demonstration of the AEDCS system. In this example, we have a data acquisition system from National Instruments, an image capture system, a separate AEDCS central server, and a screencast workstation which I'm on. All the data will be streamed through TCP/IP to NEES.org. Before starting an experiment, some planning must be done. For example, the project in this experiment is UMN, the experiment, EXP2, the trial is test. That's all site-specific. NEES information is a project ID of 8, experiment 22, a trial of 1, and a repetition of 1. Now I'm bringing up the AEDCS portal running on the AEDCS central server. You can see there are currently no clients connected. We're going to start by bringing up a remote desktop session to our time-lapse computer. It's running some image capture software. As you can see, a live view and then a preview image is being taken right now. Let's start the AEDCS client on this machine. We'll start by double-clicking the batch file. Now AEDCS is running. If we go back to our browser, we'll see the client is actually listed there. Now we can go on with further steps and configure the client. Let's configure the DAC client next. We'll bring up the DAC in a remote desktop session and find the batch script and double-click it to start the AEDCS client and the DAC system. If we go back to our browser now, we'll see the DAC system appear on our list of configurable clients. Now we're going to configure data upload using a PEN web interface. As you can see here, we have a project number 8. You enter your NEES password and your NEES project ID and hit save. Now you can see a list of all the experiments in project 8. What we want to do is create a new experiment, experiment 22, which will match the planned experiment information. Let's explore the experiment that was just created. First, we'll drop down experiment 22, open up the trial and the repetition. You can see that the default directory structure is created for us. It's the same directory structure as PEN. In the unprocessed data directory, what we want to do is create a new subdirectory for our DAC data. We'll start by creating a subdirectory, navigate back in, and what we're going to do is rename this directory to DAC because it has a default name of new folder. So we click rename and type in the name that we want and hit rename. This will actually rename it locally and on the server up on NEES.org. Next we'll drop down the directory structure to show that the directory was in fact renamed to DAC. Next we want to do the same thing for our time-lapse camera. We're going to click on the photos directory, create another subdirectory, go through the same process we did with the DAC, rename that directory to time-lapse. So here we are opening up the repetition, unprocessed data, photos, the new folder again. We'll rename it, type in time-lapse, and click the rename button. Next thing we need to do is configure the variables for the AEDCS system. In this system we can have multiple variable sets. Each set has a different name. So for this experiment we'll name the variable set UMN-EXP2 because that's the experiment that we're working on. So this variable set can have any number of variables. Each variable is composed of a key and a value. This allows you to switch between different variable definitions for different experiments. So here we're putting in the NEES.project value of 8, NEES.experiment value of experiment 22, NEES.trial trial 1, and so on and so forth. Also, we'll put in variables for the site-specific names. So MAST.project variable will have as UMN. MAST.experiment will have value of experiment or exp2. MAST.trial will have value of test. These are site-specific variables we use here for a test. Let's take a look at the time-lapse computer again. In this system there's a time-lapse mode that allows you to save pictures to a directory at a certain interval. So you can see our interval here is 30 seconds. You can see the directory where we're saving stuff to is on the C drive, and there's a temp directory there. This is important, so we're going to open it up and look in that directory just to show that there's nothing there right now before we turn on the system. Next step is to configure the data mapping for our data acquisition systems. So we'll start with time-lapse. We'll go to the time-lapse computer, look at the directory structure where the data is actually being saved, and then we'll pull up the AEDCS portal, edit the client, add a source directory, and make sure that our paths are correct. We're accepting Unix // in all cases right now. Our destination on the AEDCS central server, along with variable names. So these are the variables we configured earlier. Our NEES.project, NEES.experiment, NEES.trial. This allows us to switch those variables in another experiment, and these data mappings can stay the same for each client. This is very powerful. It saves you a lot of time and work for IT staff. And now we're going to put the data actually into the unprocessed data photos directory with the name of time-lapse, the directory we created earlier. And we hit save, and we've created our data mapping. Now we're going to do the same thing for the DAC. We're going to create a data mapping. What's different about the DAC is that it actually contains experiment information in the pathing structure. So you can see there we have the name of the MAST project, the name of the MAST experiment, and the name of the MAST trial as part of the directory structure. This is what AEDCS was built for, specific nomenclatures and directory structures. So here we're going to pull up the portal, configure our DAC system, add a source directory, and in this case we just pasted in the example directory that we had. What we're going to do is convert this example directory into a structure using our variables. So here's UMN, and that's really a MAST project. The next variable is exp2, that's really a MAST experiment. And test, which is a MAST trial. And the destination is very similar to the time-lapse client. It's opt NEES, NEES project, NEES experiment, NEES trial, and NEES repetition. All of these are variables that our system can handle and can be updated when we change experiments or change projects, but these clients can stay the same. And here we're going to put it in the unprocessed data DAC directory that we created. Next, we're going to start up both AEDCS clients by choosing the Start option in the command menu. So there we started the DAC, and now we're going to start the time-lapse client. This tells the clients to start sending data. Now that the clients are started, we can actually start a mock experiment. We've already started up the DAC software here, and we're going to actually tell it to start acquiring data from our DAC system. Now we're in the acquire mode. You can see that a data file has been created, a .dat file. That file is appended to, and the client is watching that file and sending it to the central server. We're bringing up the time-lapse computer now, and we're going to turn on the time-lapse mode by setting up a simple configuration, setting up an end date, just changing it to PM for now, and changing our interval to every 5 seconds. Clicking the start button, and we should start seeing pictures appear in the directory we were watching. There's our first picture, our second picture. It's time to take a look at our configure upload screen. We'll bring up experiment 22, trial 1, repetition 1, unprocessed data, photos, time-lapse. You can see that the time-lapse pictures are starting to appear on the central server. Then we'll bring up the DAC, and you'll see the DAT file and the OFS file have been transferred. So our clients are actually sending data to the central server. We'll shut down our clients and pretend like the experiment is over. The AEDCS system has been integrated with the existing NEES pen code. This allows us to upload data directly from the central server to NEES.org. In this case, we're just showing some of the files that have been uploaded to the central server. And what we're going to do is pick the unprocessed data directory and tell AEDCS to upload this directory to NEES.org. Here we can see the pen log window. This is the output of the pen client that has been integrated into AEDCS. You can see images being uploaded and the status of the upload as it's taking place. Here's our result. The upload was a success. Next, we'll bring up the NEES.org website and show you some of the files that have been uploaded. Start by logging in with my NEES.org account. Bringing up my projects. The top project is the one we just uploaded to. Go to the file browser. Experiment 22. Trial 1. Repetition 1. Unprocessed data. Photos. Time-lapse. There you see our time-lapse photos that were uploaded. Go back a couple pages, show you the DAC files that were uploaded. There's our DAC files, the DAT, and the OFS file, and our log directory.